Oh, hi everyone, this is Joseph from Advanced Mind Lab Technologies. Well, it's been 5 months now, and I suddenly came to my mind that hey, probably we need to update what's going on here. Maybe you guys are wondering where we are, and yeah, so well, most of us here are a bit busy with our own careers, and of course we have a lot of stuff ongoing in Mind Lab Technologies. One example that I could show you is our website. So now we have a newly updated website with much more simpler look and feel. Okay, yeah, so that's one of the updates here. You can see, well, it's pretty simple right now. Then we had enabled our downloads link. Our downloads will be hosted by Google Sites, and there you can find a bunch of tutorials. Later you'll have for electronics, hardware, embedded programming, tools, equipment, and some tear downs probably. Then we also showcase our projects, like say Bansai. You can find some infos on what are these projects are made of. You have right now, it's not yet. Then Genesis SBUZ. I think you have seen this one before. Installation packages. So yeah, so we have released our installation package that is currently 3.0, and there is an update on that would be 3.1. Okay, then yeah, so that's all about our website. Then the next thing that I'm gonna share with you is that we had migrated from MPLAB 8 point something to MPLAB X IDE, and yeah, so that's one of the major stuff that we've been doing. And then there is one of the focus that we have this past 5 months is our development of our kernel, our SBUC kernel. Well, this is a very important stuff that we've done, because this enable us to scale our what do you call this, our codes. We can somewhat like because of this we are able now to focus more on application stuff, since we already have a kernel that manages our task, and of course somewhat like abstracting our drivers. Okay, so well, yeah, so one example of scalability is that even though this kernel was written for Genesis, well, we can scale that same framework to our EHAP project. Okay, so let me just show you a bit of an example there. So you can see it's our source files. It's more simpler now. It's been we've created a more hierarchical approach. You now have apps, core, platforms. Core is where you can find all the kernel stuff. And then, so this is independent, hardware independent stuff here. Then we have the platform, which somewhat like link the hardware and the kernel, or what you can see. Probably what we have here is that the kernel stuff will link your application to your hardware. Okay, so yeah, so this is one of a big milestone that we achieved. Okay, anyway, I'll create a video on regarding this kernel stuff. So other stuff that we've been busy of is our MindLoader software. Okay, so a couple of stuff been added, like you are now able to erase. So like, let me go to bootloader mode. Okay, then from this one you will be able to do some erase. So we added that erase button there. Okay, then what else? Okay, so then we also have the pinouts for Genesis and Thunder. Like for example, let's go to Thunder pinout. Oh, there it goes. Okay, so you'll have the I/O mappings, which is very useful in during development, or you're trying to mock up stuff, so at least you know, well, what are the pinouts, what is the switch, how is it connected to the microcontroller in your system. Okay, well, also, yeah, pardon me guys if the BG is a bit shaking. I'm just using my handphone to do this. Okay, so that's one of the stuff that we've been doing. And what other stuff? So another thing that I want to show you guys is what's the importance of having Thunder in with you. Okay, so right now our eHub hardware is still under development. So you can see here, this guy is still under development, and so in order to someone like have a parallel process, like while hardware has been developed, software side can also start our development and some testing. We use Thunder to mock up eHub. So okay, I have the setup here. So now I'm using Thunder to somewhat like mock up eHub. So eHub is somewhat like a universal counter and timer, where it will be used in some vending machine applications in the Philippines. This guy here, so vending machines somewhat like accept coins and then control relays, and yeah, so because of that, Thunder have almost the features that could emulate a timer that is used in vending machines. Like I can use the push button switch to emulate the coin and some configuration stuff. Like for example, this one, and then I can use heartbeat to somewhat like emulate the relay function. And so, like for example, say for example, if I press this button here, that would somewhat like be the coin being inserted. You can see that. Okay, and then okay, the heartbeat, and then it's somewhat like, yeah. So I've been using some displays to somewhat like indicate the operation. Another stuff that we will be adding on eHub is a 7-segment display. Well, as you know, in Thunder we already have a 7-segment display, but the thing with this one is that we're trying to cost down eHub, so we will be using a smaller microcontroller on it. But of course, with our kernel as the somewhat like the core of that microcontroller. The thing with this 7-segment that we have in Thunder here right now is that it doesn't have it is using a parallel interface, which is not a luxury that we'll have in eHub. So what we did is that we were thinking of why not serialize the 7-segment and put probably a shift register at the display board. So, well, that's what we've done. So you might be seeing 4 wires here. This wires is the the supply of the board, and these are the the serial interface. Okay, so what we did is that of course we don't have the shift register at hand, so we mock up some boards, and then yeah, so this board here contains the shift registers, and this is the 7-segment display. So you can see let me just, okay, these are the 4 wires will go to the board, and here is the output of the shift registers. Okay, so since this is a 3-digit display, a 7-segment composed of 8 lines. even though it's called 7 segment, but it has 8 lines because it has the dot there. Okay, so that means that we need a total of 2 8-bit shift register, and then 8 plus, because it's a 3-digit, you need 3 extra lines to control each digit of the 7 segment. Okay, so then okay, and looking at our scope here, this is how things were being transmitted. You can see we have about 16 clocks. Okay, you can see that in here we transmitted what do you call this, the control signals, then the 7 segment data. Okay, so that's and then here's the result. Maybe the display will be a bit flickery here, but you can see the counter is doing some count thing as of the moment. Well, yep, that's it for today, I guess. That's our update, and yeah, just relax, sit back, and yeah, soon there will be more videos and tutorials on our stuff here. Okay, again, this is MindLab Technologies, Advanced MindLab Technologies, and wishing you a good day. Rock the world!